Now we're going to use a prior rule that we saw in the last video, and that is this one right here for the next 7 problems. Notice that my base here that's associated with the exponent is the same as the small base of the log. Now, the key to these problems is that you've got to get it in that form so I can apply the rule. For instance, in this first one, the base has given me a clue, so if I rewrite this as log base 12, 144 is the same thing as 12 squared. So if I rewrite that, then notice my base, my log base, and this base are the same, therefore my answer here is 2, because a logarithm is an exponent. What it takes to raise the given base 2 to get your number. This one, a little bit more difficult. But I've got to use that base. So if I put 64 here, now what do I need to raise 64 to that I could get 8? Well, if I took square root of that, that would give me 8, but I don't want a square root, I want an exponent. Remember, square root can also be rewritten as a 1/2 power. So since this and this are the same, my answer is the exponent. Another one a little bit different. Let's see, log base 3, 1 over, well, what do I need to do to that? And if you'll notice in every one of these, I've been using the given base. So, let's see, 3 to the what would give me 27. How about 3 to the third? But that is not in the correct form. I need the numerical base up here. So I've got to do a little bit more to this one. So my answer for that one would be -3. Notice this must match my particular rule in order for me to apply it. So let's play with these down here. You might have seen this one already. I've got log. It's understood to be base 10. So let me rewrite my number given as base raised to something. So my answer on this one is 2. Why don't you try this one? Pause me. If I rewrite that, I've got to go into scientific notation. So 1, 2, 3, 4. Be -4 exponent. That's that one. LOG without a numerical base is understood to be base 10. LN is understood to be base E. So this one's already ready for me. That's nice. That one is too. Now let me look at this one just a second. Well, I'd rather look at that one. I'm going to press log 0.0001. And it should give me my -4, which is what we came up with. Now I brought my calculator out because in these next problems it says to use them. To find the approximate value, round the answer to 4 decimal places. Check your answer by using exponential form. So it's rewriting the problem. So this is base 10 for 14, 15, 16, 17 is the natural log. So I'm going to press LOG. I'm going to move my calculator up. Type in 200. So 2.3010. So this is equal to 2.3010. Now I want you to see something. 2 different things here. If I raise 10 up to that answer, oh stars, I wish it was a little bit higher. I'm going to go second A and S, and that pulls down the prior answer. So second A and S, and now hit enter, and I get the 200 right back. But if I go 10 raised to the 2.3010, it will not give me right on the nose because I have rounded it. Okay, if you want to see the exact value, then you've got to use all those digits right there, and the easiest way to do that is just to pull back the answer. So I'm going to let you check these. I'm going to go ahead and we're going to find out what they are. So that would be negative 1.1308. Negative 1.1308. Natural log 200. And make sure you press the LN. 5.2983. And natural log 1.005. 0.0. And if I have to go to the fourth decimal place, that rounds that up and it'll go to 50. And if they ask you to end in a particular decimal place, that's where you got to end. Let's go back and we'll check this one. If you'll press second LN, you get e to the 5.2983. Press enter, and it should be coming up close to 200, which it does. Okay. A few other problems. There's other basic properties. If you have log 1 base b, it's equal to 0, because if you rewrote this in exponential form, anytime you raise a numerical base up to 0, it equals 1. Now this is sort of using the property we had a little bit earlier. If the base and your number are the same, it's understood to be an exponent of 1 there. So that's really applying that earlier formula. So that would equal 1, that would equal 1, that would equal 1. Log of 1 to regardless of the base is equal to 0. Now this is that prior formula that we did have. My bases are the same, so my answer is the exponent. These are easy. I like them. Now this is using that other property that we had earlier in the last video. That was b to the log b of x is equal to x. So this base and that base are the same, so my answer is 14. This one, that base and that base are the same, so my answer is 5. You do not see this often. You don't. Okay? So that's it for this video. Thank you.